Well, if we have a stain on a suspect or at a crime scene that we suspect might be blood, how do we demonstrate that it is blood? Well, there's a number of quite simple chemical tests which we can use as presumptive tests for blood. One of the old ones is called the benzidine test. This tends to be not used anymore because of the toxicity of the chemicals involved. An excellent test that gives a nice color reaction is the Kastle-Meyer test using phenolphthalein. And another very good reagent for testing for blood is luminol. All of these tests are based on the chemical property of blood, that it can catalyze the breakdown of hydrogen peroxide to water and oxidizing species. Let's take a look at the Kastle-Meyer test. What you need for doing the Kastle-Meyer test is reduced phenolphthalein. Now on the left, this is phenolphthalein in its acidic form, which is a colorless material. But in alkali, phenolphthalein loses a proton and turns into its alkali form, which is a very bright pink color. Now, if this alkaline form is reacted with zinc powder, it's reduced. And this reduced form is once again colorless. Now, in the presence of an oxidizing agent, that reduced form is converted back into the bright pink form. So if we give it hydrogen peroxide, this is an oxidizing agent. But hydrogen peroxide alone cannot turn the reduced form back into the pink alkali form. What it needs is a catalyst. And one excellent catalyst for this reaction is blood. So if we have a suspected blood stain, we treat it with reduced phenolphthalein and hydrogen peroxide, and we see the color change to pink, then it probably is blood. But it is still only a presumptive test for blood. It doesn't prove it's blood, it just says it's most likely to be blood. This is because there are other materials, not just blood, that can catalyze this reaction. For instance, a potato. It turns out that there are very powerful enzymes in potatoes, which are excellent catalysts for this reaction. So potatoes are one example of something that can give what we call a false positive in the Kastle-Meyer test. There's a mysterious stain on this piece of tissue paper here. It could be a blood stain, but then all blood stains just look like brown stains. So it could also be paint or chocolate or something like that. But what we're going to do is to use the Kastle-Meyer test to find out if that is a blood stain. This is just a little bit of ethanol. This is the Kastle-Meyer reagent from reducing alkaline phenolphthalein with zinc, and you can see a little bit of the zinc in the bottom of the vial. And you notice when we add the Kastle-Meyer reagent, nothing happens. That's because we haven't added the oxidizing agent, which is hydrogen peroxide. And this isn't the dilute kind of hydrogen peroxide that some people might use to bleach their hair. This is 30% hydrogen peroxide, and this will burn holes in your epidermis. And you immediately see the pink color as the hydrogen peroxide reoxidizes the reduced form of phenolphthalein a reaction that is catalyzed by blood. So probably that brown stain on that tissue is blood. Well, the Kastle-Meyer test is not perfect because a number of substances will also give the positive result, that is so-called false positive. And one of these substances that will do this is the humble potato. So here's a potato. I'm going to treat it in exactly the same way. That was the ethanol. This is the Kastle-Meyer reagent here. And finally, some hydrogen peroxide. So potato's a little bit slow till it goes pink. So if you've done your Kastle-Meyer test or your luminol test and you've determined that a stain found at the crime scene really is blood, there's still the question of whether it's human blood or whether it belongs to some animal. And we can use antibody technology to determine which species blood comes from. The way this is done is that a sample of human blood is injected into a rabbit. The rabbit's immune system reacts to the presence of the human blood and it produces antibodies against those components in the human blood. So serum from that rabbit's blood can then be used as the test reagent. For instance, if we take our suspected human blood and treat it with the rabbit serum, then when the human blood meets the rabbit serum that contains the antibodies, then the antibodies, of course, will bind to components in the human blood, and there will be a distinctive sign that there is an interaction. If the two interact, then it proves that the sample is from human blood. This is usually done in a gel. So the antigen and the antibody are placed in separate wells in a gel, and then using an electric field, they are induced to migrate towards each other. If there is an interaction between the antibody and the sample when the two meet, then there will be a visible precipitin line in the gel. If there's no interaction, then there is no visible line, and you know that it's not human blood after all. This kind of technology is important. It has been used. For instance, some years ago, this man, Christopher Nuds, was accused of killing his friend, Fred Moss. Part of the evidence for this accusation was the presence of many bloodstains in Christopher Nuds' Range Rover. But it turned out that Nuds was a hunter. So the bloodstains presumably were from some of the birds and animals that he had captured and killed and driven back home in his Range Rover. So the Precipitin test had to be used to find out from which species all of these bloodstains came from. And sure enough, most of the bloodstains in the Range Rover were from hunting. They came from birds and animals such as rabbits. However, that was most of the bloodstains. It wasn't all of the bloodstains. Some of the bloodstains indeed turned out to be human. Once the human bloodstains had been identified, then it was possible to use DNA to find out whose blood it was. And it turned out that human blood in the Range Rover matched Fred Moss. Christopher Nuds was subsequently convicted of this murder, and it's going to be a long time before he goes hunting again.